Chapter 7, we're going to talk about chemical reactions. Grade school volcanoes. They used to call this kindergarten volcanoes, but I don't know of any kid that makes a volcano in kindergarten. Did you ever make a model of a volcano using baking soda and vinegar? Or maybe somebody in your class did, and it's even more fun if you put some red food coloring in there so it actually looks like lava bubbling out. That's an example of a chemical reaction. Baking soda is sodium hydrogen carbonate. It will react with the acetic acid in vinegar. It forms carbon dioxide gas, water, and sodium carbonate. The carbon dioxide gas is what causes it to bubble and foam and rise up out of the volcano. So a chemical reaction is the transformation of one or more substances into different substances. A chemical reaction is a chemical change. We've talked about chemical changes. This particular example is an example of a gas evolution reaction. It's a reaction that occurs in a liquid state and it forms a gas. So there are different types of reactions, and we're going to learn about the different types of reactions. There's a chemical reaction that occurs in your gasoline-powered car that causes the engine to move the wheels. Hydrocarbons like octane that are in the gasoline combine with oxygen from the air, and they combust, and they form carbon dioxide and water. They form a lot of gases which expand and cause the pistons to move. So you've got little explosions happening in the cylinders of your car, and when they're coordinated correctly, your car moves forward nicely. This is a combustion reaction, which is a subcategory of oxidation reduction reactions. So here we have octane reacting with oxygen, forming carbon dioxide and water. These atoms are not changed. They're like the Lego bricks. You take apart the little house that your sister built and you make a jet engine out of it. You take it apart, you put it back together. The atoms are not being created or destroyed, they're just being rearranged. In an oxidation reduction reaction, we have electrons being transferred from one substance to another, and that's what characterizes that. Laundry detergent. Around here we have hard water because most of our water comes from wells, comes from groundwater. The reason that you use laundry detergent instead of like liquid hand soap is that laundry detergent has substances in it that soften the hard water. Those calcium and magnesium ions that are dissolved in hard water form this yucky scum with soap, and so you don't want that all over your clothes. So the hard water has dissolved calcium and magnesium ions, and they make this curd or soap scum. So here we have soap in pure water, and it gets all nice and bubbly, and here we have soap in hard water. And it doesn't foam up nearly as much. And look how the water is kind of dingy because it's forming this insoluble substance. And that's one of the things that causes your white clothes to get gray after you've washed them several times. So how does the laundry detergent do that? It has things like sodium carbonate in it, sodium carbonate Na2CO3. This dissolves in the water in your washing machine and forms carbonate ions. Well, the carbonate ions react with the calcium ions and the magnesium ions and form solid calcium carbonate and solid magnesium carbonate, which those will settle out. They don't form this slimy curd. They form a real solid that will settle out and get rinsed away. This type of reaction, we're forming a solid substance in water. These are called precipitation reactions. Because if you watch a precipitation reaction, a lot of times it'll almost look like snow falling down. And what does a meteorologist call snow? A form of precipitation, right? Something falling down.